Yeah. So it's just now 12. I think we'll just get going because I am your last obstacle before lunch. So we'll get started. So hello. Thank you all for coming on this lovely final day of Global Summit. I'm Michael Smart, and this is going to be REST at Ease, a look at API design and development with InterSystems Iris. So let's take it easy, shall we? We have a brief overview of HTTP, the building block of REST services, and we'll see how we get from the base building block to the REST design principles. We'll look at Swagger, a way to develop a specification of a REST service, which can be consumed later by clients and other tools. There's two approaches to developing a REST service in Iris, and we're going to cover both, the code-first and the new spec-first approach. There's a little bit about the JSON adapter, a new way to easily transition between your persistent classes and a JSON representation. And then finally, JSON formatter, a pretty printer for JSON strings and streams. We'll take a brief look at the API manager and how it relates to Swagger specs, and then save time at the end for questions. And if you were curious, all the code that I'm going to demonstrate to you today is available on our GitHub page in the REST at Ease repo. So let's begin with building an API. And the best way to begin to learn about something is to start with the building blocks. And so when you view a website in your browser, you're making HTTP requests that look just like this, a GET for index.html. Notice how there are two components to the request. We have an HTTP method, the type of request being made, and a resource, some item on the server that we'd like to either access or manipulate. And so the REST design principle comes into play as a very thin layer on top of this protocol. And it says, when you're deciding what you're going to have for your web service, what your different endpoints are going to be, the combination of an HTTP method and resource, think about the things that are in the domain of your application. So what types of data do you deal with? Is it patients, or maybe car rental reservations, or pizza delivery or something? Or as you're going to see later in one of my examples, a conference room reservation app. So meetings. You don't need to say get meeting as your resource because the method already describes the action that's going to be taken. So just decide on what your resources are, and then you can differentiate between different actions in your web service by changing the HTTP method using the same resource. And so here's the top four most common you're going to see when you're dealing with REST. And next to it, an expectation of what will occur when that type of request is made to the server. So we have a get, way to retrieve data, post and put, which are two methods for sending data to the server to be processed in some way. There's also a patch request that you might sometimes see for partial updates of information. And finally, a delete. Now, the thing to remember about this is that these aren't rules as such, right? These are the expectations for what will happen when this request is made. So it's helpful to you to follow these guidelines such as they are. Like you wouldn't want to have a GET request that allows you to submit data to the server to be saved, because that's what the POST request is for. But there's nothing saying that every POST request must result in something being saved on the server. So there's flexibility there. And the idea with the RESTful design principle is to eliminate guesswork, both for you, the developer, in deciding what your endpoints are going to be, and for a client coming to this from nothing, being able to look at the operation of your web service and then have an easier time debugging and understanding what's going on. So as you build up a series of these things, you now have your interface, your REST API. And here we have 5 activities centered around this idea of meetings. And that's great on paper. But how do you really design one of these things that's going to be maintainable and most effective for someone to actually use? And as I see it, there are 3 challenges or objectives that you need to overcome to reach that point. Describe the interface, handle input and output, and tell the world how to use it. So step 1, describing the interface. This right here is a good starting point. It's the backbone of your REST service, the endpoints, the different things you can actually do. But if you dive deeper into this, I mean, let's think about what it actually means to create a meeting on the server. What is a meeting? What are the different pieces of information contained within a meeting? Are there required fields where I need to always include this piece of information for this type of request? Is there a format that you expect to see? And what I'm talking about is a schema. Can you tell me exactly what a meeting means to you, the service? Are there error conditions on your service that I need to be aware of as a client to write code to represent all of your data structures and handle all the different situations that may arise? And then just more general purpose information, like who maintains this service? If I have a support question or need to get some kind of technical assistance, is there an email address of someone that I can contact? What are the protocols that you support for this service? Is it just HTTP? Do you have HTTPS? Is there basic authentication or some other method? And so on. Handling input and output. There's many ways to represent data. Which ones does the service support? Is there a way to move easily from an internal representation of this data? So in other words, a persistent class in your Iris database, and any number of formats. So JSON, which you'll see most often with REST, but you could also have XML. You could have plain text using some kind of delimiter that you've come up with, and even combinations of these formats. Like you can support more than just one. You can say, if the content type of my request is XML, then we know that what the client wants is XML to be sent back. So we need a way to kind of translate between these many different types of data representations. And then lastly, tell the world how to use it, because your finely crafted API isn't going to be much help to you if no one can figure out how to first connect and then actually speak your language, this protocol that you're developing with your interface. And wouldn't it be nice if we could leverage what we've learned in solving problems 1 and 2 to arrive at some kind of automatic documentation, which you're going to see as we go over this in the next half hour. So we'll go into step 1 here, objective 1, in more detail. I already described to you the types of information we'd like to see. But what I'm most interested in knowing is whether there is a standards-based approach to solving this problem. And the answer right now is the OpenAPI Specification, more commonly known as Swagger. This is the branding that has come about from a series of open source tools designed to work with the OpenAPI Specification. So I'll show that to you right now. The best way to kind of understand is to just look at it. And so here we are in the Swagger editor, one of many. That is not the Swagger editor. That's where that goes. OK, sorry about that. So this is the Swagger editor, one of many tools provided by the Swagger people. And this is how you are able to both view and edit a Swagger spec, which describes a REST service, as you see. So it's the greeting service right here. There's one endpoint, the hello world endpoint, where we can return the hello message. And the important thing to note is the JSON document being edited on the left-hand side here is the REST service that you see on the right in this automatic documentation view. So this is really a what you see is what you get kind of editor. I can even go in and make little changes here. And you see they immediately take effect in the right-hand view. So this is the tool to use to begin designing your service. Now hang on to that for just a moment, because we're going to move into looking at how this works in Iris. So hang on to Swagger for just a moment. We're going to talk about how we actually implement REST. And as I mentioned before, there are two approaches. You have the code-first approach and the spec-first approach. You need to begin by either writing code or designing your spec that describes the service in the editor, as I just showed you. If we do code first, we can generate a Swagger spec on demand when we need it, although it is limited, as I'll explain in a moment. And with spec first, we can generate code, because we look at the endpoints of the service. We know how to set up the kind of glue code between a client and the back end on the server. Now, are there pros and cons to each approach? Yes, and let's get into that right now. Let's try and first look at how a REST service actually works in Iris. So this is the main component right here, the dispatch class. In the code-first approach, you need to actually write this yourself. But with spec-first, we can generate it for you. And as you see, it kind of resembles that table I showed before. There's a list of endpoints here. And when we get a match, when we receive a request that matches one of these routes, we call into the class method to then implement your business logic that you've created. Now, if you have gone the code-first path, if you've written that class yourself, your own dispatch class, you can get a Swagger spec on demand, as I said, by using this REST endpoint, API MGMNT. What this does, I'm not going to demonstrate this to you now, but it will return a list of the REST services that are available on that Iris instance, with the option to drill down into each one and get the Swagger spec. Now, I said it was limited because we are limited in the information that is available in the dispatch class to actually collate and then give to you in the Swagger format. So things like schemas are not available. The descriptive information, the higher level general information about the service, we can't give you that, but we can give you the list of endpoints and any information surrounding those that you've provided. Now, what I want to do at this point is compare the two approaches as they relate to client-server relationships, which you might find yourself in as developers. Now, in the case where the service defines the interface, the back-end team drives the relationship. So we are crafting a service and then pushing that spec down to any clients who want to use it. So if the Swagger spec does not exist independently of the code, if it is a byproduct of the code, as it would be in the code-first approach, that can work perfectly fine because there's no reason to edit the Swagger spec. We just change what's in our code, and then that becomes the representation of the service that the client can take and run with. And Spec-first can work perfectly fine as well, because if we've developed the spec beforehand, each side can generate the code they need. But now let's look at this situation, collaboration, where we have a front-end and a back-end team, perhaps in the same company, working together, and each has their own requirements on what the service needs to do. So the client says, we need the service to implement this way to access some data because we have our own requirement. The design document says we need to provide this feature. So code-first can't work here for the back-end team. We can't, or we wouldn't want to only make updates from one side. It would be great if both of these teams could work together and collaborate on the Swagger spec. So we both agree on what the idea of the interface is, and then each go back and generate code as we need it. And then finally, you might find yourself in this scenario where a client is going to be making a certain type of request or a series of requests to you, and they're asking that you implement some sort of standard. Well, code-first really doesn't work in this approach because we need to iterate faster than that as the spec changes. It's going to be coming into us from someone else. And so the spec-first way of doing things would be the best approach for this as well. And so this is the difference right here, to boil it down for you. With code-first, the code is the source of truth for the service. The Swagger spec exists as a byproduct of that, which can work fine for some relationships between client and server. But I hope you'll see and can appreciate the benefit of the spec-first approach, particularly for new API development in Iris. When you elevate the Swagger spec from just a mere design document or just, as I said, a byproduct of code you've written, it becomes a first-class citizen in the design process and now can function as a contract between client and server. We guarantee that if you send this type of request to me, you will get this data back. And it has to work that way because we've generated code on both sides based on that spec. And once you do that, you can really get off to the races with your Swagger spec. You have the option to generate interactive documentation. As you saw in the Swagger editor, we're able to do that. And then even unit tests and other types of activities surrounding the interface that can be generated automatically with the spec-first approach. Before I show you the demo, let's just take a look at what needs to happen when Iris receives a request for a REST service. So there is the dispatching element, as you saw before. We have a dispatch class that needs to look at what request has just come in and then correlate that to some piece of code on the server. So for the spec-first applications, we looked at this relationship and we said, this is really two different things. These are two different classes. Because the dispatching is quite often boilerplate. You don't really need to do much more in there than grab parameters that come in from the request, or maybe figure out which content type was requested, and then have your business logic, which is the actual implementation of the back end. So we said, let's just have 3 classes. We can have a container for the spec, keeping track of that as it changes, and then derive the other 2 classes, the dispatcher and the business logic, which we partially update as the spec changes. And so now I'm going to jump into the demo for this and show you what we've got. So I find myself here in the terminal. And the way to get started with the spec-first development is to call this routine right here, $%rest. It's a command line tool for creating the spec-first applications. And so it asks for a name for the application, which, to jump ahead, is going to be used as the package name for classes we generate. So if you're going to integrate this with an existing code base, that's just something to be aware of. So I'm going to use this service that I've already shown you in the editor, the greeting service, as an example. And we want to create a new application for that. And then it asks, where is your Swagger spec, if you have one, to use and pre-populate the service you're about to create. So I put in the path for that. We're going to confirm, and then it says, here are the 3 classes we just generated for you, the spec, dispatch, and implementation class, as I said. And then lastly, it asks if I want to create a web application so we can get this up and running quickly. And it's going to automatically, behind the scenes, do all the wiring that it needs to do. If you're familiar with the code-first approach of setting the dispatch class yourself, this takes care of all of that for you. And I'm going to change that from the default to be just greeting, like that. Now I'll jump into the editor and actually show you the 3 classes right here. So this view on the left is a little small, but I think the code will, yep, there we go. So this is the spec class. This is, as I said, just a container for the spec that we sent in. As you see, we have our one endpoint there, the hello message. The dispatch class, very similar. One endpoint in our URL map. Now remember, in the code-first approach, this is something you needed to write yourself. But with spec-first, we take care of all of this for you, recognizing the existence of boilerplate code in this approach. And then lastly, we have our implementation class, where we have a stub method already set up for the hello message. So I'm going to actually copy that to my project, because this is where I'm going to make my code changes. We pick up descriptive text from the Swagger spec to actually put in as comments to help you remember which function this actually is. There's even some helpful startup code here for some of the common things you will need to do, like setting the status code and so on. But all I need to do is return the hello world message here to satisfy my requirement. Now you may notice that the method which was generated returns a stream, as you see. But the dispatcher is sophisticated enough to recognize what we send back. So if I return a string here, as I've done, it will do the appropriate thing. It won't try to call a read method on the string that doesn't exist. And I'll prove that to you now by pulling up Postman, my tool for testing this REST service. And I'm going to make a request, a GET request, to the greeting hello endpoint. And as you see, there's the hello world text that I expect to see. I'll now show you another way of updating the Swagger spec, other than just using the command line tool. I'll show you the API management service that we've set up for the spec-first application. So if you look here, that is API MGMNT v2. And if I make a GET request there, you see we have a list of the spec-first applications that exist on this Iris instance. And I have the option to drill down into the greeting service that I've created, so I'll just copy that little URL snippet there. Add that onto the end. It's the user namespace and a service called greeting. And so here is my spec, once again, the same one that I sent in with all of the detail, additional detail that you wouldn't get in the code-first approach. And so now I'm going to actually show you how you can update this just using Postman right here. I need to grab my version 2.0 of the spec. So we've added 2 endpoints to this now. We have an option to get and set a custom greeting message. So if I take that again, I'm going to make this a post request instead of a get, using the same resource. As you see, we've adopted the RESTful design principles for our own service here. And I'm just going to send in the updated Swagger spec to this same resource. And we get a message here. The greeting application was updated. And so back in the code, we can see what effect that has had. In the spec class, we have our hello endpoint, and we have 2 for the message resource. The dispatch class was updated. We now have 3 endpoints there. And the implementation class, I know has changed on the server, so I need to, in Atelier, actually use the synchronize function right here on that file. And I'm going to take the server's copy of that. So back over here, you see the hello method is still there. That was unchanged because the way this works is we only update the implementation class in a non-destructive way. We don't interfere with any of the code you've already added. We will only add stub methods for new endpoints that are created, and also update any parameters if those have changed in the spec. So we have 2 new methods now to deal with, a get and set message. So let's begin actually implementing this. I'm going to use the message global to store the custom message that I want to send. And we'll use a $get to allow me to have a default message if the global is unset. And I'll demonstrate that here again in Postman. If I change this to the greeting message endpoint, there's my default message if we haven't set one already. And now in set message here, you see we've created a parameter for the request body that's going to come in, recognizing that this is a post request. And I can actually show you where that comes into play. Right here in the Swagger spec, you see there's an option to list the parameters, and we have an area, a place to specify that it is the request body coming in. And to help me remember that, I've just gone ahead and named that body. So this is a stream, so I need to actually call the read method on that. And there we go. Now I'm going to do something that's incorrect on purpose to demonstrate one of the pitfalls of this approach that you may run into. So if you look at the code here, it seems like I've done the correct thing. I've set the message global based on the incoming data. But if I make a post request to this resource, setting my custom message here as the request body, you're going to see an error come back. Now, why did that happen? Well, one of the things or stipulations with this approach is that you need to be explicit about what your response body is going to be. So even if it's empty, you need to quit the empty string to be very precise about that. So it's just something that's going to come up. You're going to run into this, so just be aware of that fact. And if I make that request again, you'll see we now got 200 OK. And I can make a GET request now to receive my custom message. Last thing before we move on from this, I want to convince you of the non-destructive approach to our updates in the implementation class. I'm going to modify the spec again. And maybe for version 3, we've now decided that we don't need that hello endpoint anymore. We're happy with having the custom message that we can set. So I'm just going to remove that from our list of paths. Make another update to the greeting application. Now you may be wondering, when I do this, when I make changes, will the service still function as it did before? So if I make this request to get my custom message, is that going to come back? Do I need to recompile or do anything else? And there you have it. The answer is no. So what we've done in the implementation class, if I update this again from what's on the server, you'll notice that not much has changed with it. You see, the hello method is still there, even though that endpoint has now been removed. It's been deprecated. So again, this is about coding with confidence. right? We do not remove any of your own code when you do this. This business logic class is the place for you to implement the backend. The dispatch class is something that we generate automatically for you. So I'll show you that updated as well. And you see we're down to 2 endpoints here for the dispatch. So back to the slides for a moment. And I believe the next few slides just cover some of what we've just discussed. So here's the separation of concerns between the dispatch class, where you're going to find some of the boilerplate operations, things you need to do for every endpoint, and your actual business logic. And when the spec is updated, we throw away the dispatch class and regenerate that from scratch based on the updated spec. The implementation class is partially updated to implement any new endpoints or new parameters that you've added. And we talked about the API Management v2 service, where you can actually look at your spec and then make updates to it. So there's 3 methods for doing this, updating the spec for one of these spec-first applications. And I showed 2 of them. So we have the command line tool, *rest. And you might imagine if you were connecting to the Iris instance via the secure shell, SSH, you're already in the terminal anyway. So this may be the most comfortable approach for you to actually update your spec. The API, the v2, is very convenient as well. You could imagine that in the example of the back-end and front-end teams, if the front-end people are not Iris developers, they may be more comfortable working with the spec in this approach. Like you could imagine maybe there's an Iris instance that is the staging area for the spec that we're developing. And so each party can make changes to that. Lastly, we have this class method here, createApplication, which despite the name, you can use to update an existing application if you provide its name. Now, I could envision this being used in some kind of script that you run automatically. Maybe you're pulling a spec down from source control, and then you want to make updates to your classes as that changes. There's actually a secret 4th method to this. You can just update the spec class that we generate. And when you compile it, we will update the other 2 classes. Let's talk about JSON. We need to take a look at ways to have more complex REST services that don't deal in just plain text. And I've created a second example application for you. You see the creatively named lookout for meeting reservations. And the data model for this is as follows. We have a list of meetings with their own properties, and it is connected to the person class via the host and attendees property. So the host of a meeting, the list of who's going to come to it, and the room in which the presentation or meeting will be held has its own properties, like what is the capacity of the room, so we can assign things appropriately. So that's another object relationship. And the challenge that we're going to have with this is how to actually represent all of these object relationships in the best way for each endpoint that we need to implement. So I'll go ahead and pull up the information or the spec for the Lookout app, just so you can see it briefly. And I've already gone ahead and imported this into Iris to save time. So we have 4 endpoints. We want to get a list of all the meetings that are on the schedule. We want to have the option to create a new meeting, get detailed information for a specific meeting, and then finally make some update to a meeting. Like maybe we want to change what room it's going to be held. So let's now go into the editor and just begin writing this up. Here's my implementation class with the stub methods. I've already gone ahead and added some code here that we'll need. So to get all meetings, we have this SQL statement here. I'm getting a result set by running this query, and then I want to iterate over the results so I can get each row back. And you'll notice here this interesting syntax. So this is the first piece of the JSON functionality that I want to show to you. Now this has been in the product for a little while, but this is actually an example of the dynamic object API. So when I put down these square brackets like this, which is JSON syntax, we are going to have a dynamic array in this variable. And so I have the ability to go from that representation to JSON very easily by just calling a %toJSON method. And what I'm going to do is actually just push, using the %push method, dynamic objects that I create right here, just inline in the code. Now, we break with JSON syntax in this way. When you need to have an object script expression, or you need to refer to a variable that exists in the scope of your method, you need to enclose that in parentheses. And that's just so the compiler can know this is an expression, this isn't part of the JSON string that we're creating. So if I build this out, you'll see I can refer to the title. I can grab the name of the room. And then my method returns this dynamic array that we've created. So I can call to JSON like this. I can actually just quit the array because the dispatcher would be sophisticated enough to recognize what it is and then serialize that to the JSON string as needed. But I'll show you how to do it this way. So back in Postman, if I go to my third tab here and make a request, this is the lookout meeting endpoint. So just a slash. Here is the list of meetings from my application in JSON format. So now, next thing, how do we get detailed information, more than just these 3 fields? Well, I could do the same thing again, create a new dynamic object, and then populate each of the fields. But we have the question of how to handle the object relationships, like when we need to talk about the list of attendees. Do I go down and have a for loop that just goes through each one and builds up a dynamic object for each person? Could do that. But there's an easier way. And this is a new feature to InterSystems Iris. This is the JSON adapter. So if I pull up my lookout meeting class, the data class I've been using, you can see it has this dependency of the JSON adapter. And what that allows me to do is the following. So I'm going to say do meeting JSON export to stream. I pass my stream by reference. And then if I return the stream like this and make that request right here, so we'll grab the strategy meeting, you can see the full detail of my object comes back with just that one method call. Now, to expand on that a bit further, I can get finer control over what JSON is returned through the use of mappings. And I'll show you one of these right now. You'll notice this xdata block here, basic info. And this refers to a JSON mapping that I have on this object. And so when I specify that I want to export using basic info, we take a look at the fields, the properties of the class that have been specified here. So the ID, the title, and then the room, and populate the JSON accordingly. So notice here I have this field, the reference. We're going to refer to the room, an object relationship, just by its ID, rather than doing what we've done here, going down into the nested object. So if I go back and say I want a JSON export with basic info instead, I can make that request, and you see we now have just the 3 properties that I specified. We can use the mappings, and this is a very powerful feature of the JSON adapter. We can go the other way and say, I want to import JSON into an object based on a particular format. And this allows us to reference existing objects in the database by their ID. And I'll show you that right now when we go ahead and create a new meeting. Now, I have the mapping already set up for this, and it's called new meeting. And you see 4 fields here. Host and room are going to be referenced by their ID. And I have the option to specify an alternate field name for this title. Maybe that's a little vague, and we'd prefer to just say, what's the name of the meeting? What's it going to be called? And so I'll show you how that works now. If I call instead JSON import on this object I've created, passing in the body, the request body as my parameter, and we say it's going to be the new meeting mapping, and then save it. Well, what I can do now is make a post request. We have this. This returns the list of meetings. I can make a post request to the same address and specify what I want to have for my new meeting. So we'll say the ID is test. The name of meeting is test meeting, like this. The room is going to be Clarendon, let's say. Host will be Adam. So we got a 200 OK. Hopefully that was saved into the database. And if I make a post request to get the list of meetings we have, there's the test meeting that we just set up. And so last thing I want to show is making updates to an existing object, our final endpoint that we need to implement. So for this, let's just say we want to give the option to change the room for the meeting. And that will be enough for this endpoint. But we only want to enable that change. We don't want to give the option to change the title or the host of the meeting and so on. So I'll say JSON import again. We're going to use the body. But I'm now going to specify room only, which is one of the mappings that I have in my meeting class. And we'll save that. I'll show that to you before we move on. So you see the room only mapping. The only field referenced here is the room, referenced by ID. And it's an input only parameter. So I couldn't use this mapping to export. That's just if that's your preference and you want to restrict certain mappings for certain things, you can do this. Like maybe the ID is something that would be input only, let's say, or output only. You have the option to go either way. So now I'm going to make an update to this test meeting. And I'd like to change the room, but not the title of the meeting. So if I go here again, we'll make a put request instead to this address. The room will be Exeter. And we'll say the title is going to be changed meeting. I make that request. We got a 200 OK. And I can look at the details of the meeting. And you see the title did not change, but the room has been updated to Exeter. So now just a brief overview of the two approaches. Here's our dynamic object API. Oh, come on. There it is. Dynamic object API, you see the parentheses where we break with the JSON syntax. If you need to refer to an object script expression, just enclose it in the parentheses. %2JSON is your way to export, flatten that into a JSON string. And then %from JSON, which I didn't show, but that allows you to go the other way. Take a JSON stream and get one of these dynamic objects. For the JSON adapter, now you don't need to use the JSON adapter to have dynamic objects. You can put those anywhere you want in your code. But for a registered object or a persistent class, if you want to do the JSON import and export, as I just showed you, you need to add the JSON adapter as one of its dependencies. And so here are the options for the mappings that you can set up. And some of them I didn't show. Like you can have nested mappings. So I could say for my room object reference, I want to refer to a mapping that was set up in the room class to restrict how the object is serialized to JSON. And then as you see, JSON export and import are the ways to go to and from JSON. Last thing, the JSON formatter, which in simple terms is a pretty printer for JSON strings, giving you the option to have indenting and new lines. So the best way to demonstrate that is to just show you. So I will call a method that I created earlier to get a dynamic object. There it is. And now if I call toJSON like this, it's not too long, but it's not the easiest thing to read when it all runs together like that. So I'll show you where the formatter can help you with this. I'm going to set this up, %JSON.formatter. I create my new object, and then I call formatter.format, capital F, and send in the dynamic object. And you see that's much nicer to look at. So if you have a use case where you're exporting JSON to maybe a log file, or you just prefer to look at it like this, this is the solution for you, the JSON formatter. And this is a new feature in InterSystems Iris. Last thing I want to show you, just very briefly, is a look at the dev portals in the InterSystems API Manager. Now you saw this earlier today on the main stage. I just want to show you one piece of how this integrates with the Swagger specs that we've been talking about and developing. So my lookout spec I've already gone ahead and imported that into IAM, as you see. Here's the spec that we've been working on for the past few minutes. And if I go here to my dev portal, we have the automatically generated documentation, as you see, with the option to test each one of these endpoints. So right here, the list of meetings, I can go and make that API call, and there's my list. And I can scroll down here and see all of the different endpoints that we set up for this service. So a real benefit for clients and developers who need to get onboarded with your service. So we're coming to the close of this presentation. I want to bring to your attention some of the companion presentations that cover some of the same material, which I invite you to take a look at on the online learning page when the videos are up. There's no more option to see any of these. We're at the end of Global Summit. Also, please remember to submit your survey in the Global Summit app. We appreciate your feedback for this and future Global Summits. And I thank you very much for your attention. There's a microphone set up if anyone has any questions. Not the most enticing offer right before lunch, I know, but it is an option. All right, well, thank you very much. Have a safe travels back home. We'll see you next year.